Alright, today what we're going to talk about is navigation. Okay, to do navigation, we're going to go ahead and need to remember that if we take a look at the compass, I like to call it the compass rose, but the compass rose, north is up here at 0 degrees, east at 90, west is south is 180, and west is at 270. We had that in our reading, a little nicer picture of it here, but we already talked about that. We're going to have to know that it's a little bit different than doing a protractor, okay? Now, before I even start these problems, I take a look at where I think I'm going to go, because if I drew it wrong, for instance, if I drew this whole picture and I started here, the whole journey is going to go this direction. So that's going to be off my paper. So I read it first, figure out, okay, where should port be? So two ships leave port at the same time. Ship A travels a bearing of south 35 degrees east. So he's going south, okay, on 12 knots. Ship B goes south. So that means that, actually I said it backwards. I actually want to start up here because my ships are going down, right? So maybe I'll start and put my port right here. I'll put a dot, call that P for port, because both ships are going south. One's going southeast, the other's going southwest, right? When I draw my port, the next thing I want to draw is my compass rose, because they're going to take the compass rose and they're going to navigate. So drawing my compass rose here through port, and then each boat can use that for their own bearing, all right? So ship A is going to travel at a bearing of south 35 degrees towards the east. So ship A is going to look south, and then he's going to turn 35 degrees towards the east. So he's going to kind of head that direction, all right? So to get exactly what it is, I'm just going to use my protractor. I'm going to zero it out for south, and then I'm going to rotate 35 degrees towards the east. 10, 20, 30, 35, okay? So I want to draw a pretty accurate picture so I get an idea of what's going on. Now, 12 knots, I'm just going to draw it 12 centimeters and call it 12, right? So I'm going to go ahead and just draw this 12. Okay, it's way down there, that's right. There's ship A. I'm going to label some things. I know that this is going to be a 35 degrees, and this is 12, all right? Ship B, same thing. Ship B is going to face south, but he's going to rotate 15 degrees towards the west. So he's going to be heading kind of in that direction for ship B, right? So it's face south, and we're going to rotate 15 degrees towards the west. 10, 15. And then what I'm going to do is draw that in 8 centimeters to call it 8 knots. Knots is a rate in boating terms, how fast, nautical miles per hour. So I'm going to go ahead and draw that in. There's ship B, call that 8, and I'm going to label everything. There's my 15 degrees, all right? Now, first thing is, how far apart are they after 3 hours? So let's go ahead and draw that in. So this is the distance that they're apart. I'm going to call that C, but after 3 hours, then the triangle is going to really be 3 times as big, because it's going to go for 3 hours. So multiply this by 3, and that becomes a 24. Multiply that by 3, and that becomes a 36. All right. This angle is going to be a 50-degree angle. 15 plus 35. Okay, I have my side angle side. Because I have my side angle side, I'm just going to use the law of cosines to find little c. So I go, all right, c squared is equal to adjacent squared, 24 squared, plus adjacent squared, which is 36 squared, minus 2 times 24 times 36 times the cosine of 50 degrees, all right? I just have to do the math, put it in my calculator. So I'm just going to go, all right, put 24 squared plus 36 squared minus 2 times 24 times 36 times the cosine of 50 degrees. And of course I need to take the square root of that. So I've got c squared equals my 761.2 blah 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 blah. We'll take the square root of both sides to get c by itself. Take the square root of that answer, and I get about 27.6. Okay, that answer makes sense. 27.6 always makes it good if my answer concurs with my problem. Okay, good. That's in terms of knots. Okay, that's pretty easy. That's not too hard at all. Now, part B says if ship B becomes disabled. Okay, ship B is disabled. What bearing must ship A take to rescue? Okay, so here's ship A way out in the ocean. Ship B is disabled. So ship A has to stop, turn around, and head towards B. So he needs to get a bearing. So I'm going to draw compass rose in for A because he's going to have to get a new bearing. So put a compass rose down for A. Here's my north, east, south, and west. Now, the compass itself needs to turn and read this entire rotation. To get the correct bearing, the compass is going to read that bearing right there. So what I need to do for this bearing is I know part of it already. You notice the 90, 90, 90. I know certainly 270 degrees plus this angle here. We're going to call this angle theta, okay? Now to get theta, what I need to do is find some more information, right? So what I know is we did a little bit of this way back in geometry, but you can see, remember the Z in geometry, alternate interior angles? I'm going to draw that out. Okay, remember alternate interior angles way back in geometry? I know that this angle here, because these are parallel lines, right? This is south, this is west, east, west, east. These two lines are parallel. So in geometry we learned about alternate interior angles. I know that this angle will be congruent to this angle, right? So if this is 35 and 90, then this angle here is a 55 degree angle. This angle is a 55 degree angle, which means the entire angle here is also 55. Okay, the way I'm going to tackle this problem is if I can find angle A from the angle of the triangle, I'll find angle A using the lost sign. So I'll get angle A here. I'll subtract it from 55, and that'll give me theta. Okay, I need theta. So I'll get angle A from the lost signs. If I get angle A, 55 is the entire angle. I'll subtract 55, and that'll give me that little angle there. Okay, so let's go ahead and do that. So first of all, if I want angle A, I'm just going to set the lost signs. I'm going to go sine of angle A over its opposite side, which is 24, will equal the sine of probably 50 over its opposite side, which we can do. So I can go sine of 50 over my 27.6. And then if I cross multiply, I'll get angle A. And then I can subtract 55 from angle A. Okay, so let me go ahead and do that. I'm going to go ahead and multiply by the 24. I'll have sine of angle A is equal to my 24 times my sine of 50 divided by my 27.6. I'll get a decimal. And then I'll sine inverse that, right? So I'll go 24 sine 50 divided by 27.6. Get a decimal, like I expected. And I'll sine inverse that answer. And I get an answer about 41.8 degrees. Angle A is about 41.8 degrees. All right, now let's take a look at our picture, okay? So I found angle A. Angle A is 41.8. I need this tiny little angle here because my bearing, let's go back to it, my bearing is going to be turning my compass all the way around to this bearing right here, okay? I'm going to go 270 plus this little angle, okay? To get this little angle, I know the full angle here is 55 from my alternate interior angles, minus my 41.8 will give me this little angle here. So theta, finally almost there, theta is going to equal my 55 minus my 41.8. It sounds like Colby's already got it. 55 minus 41.8, and I get an answer of 13.2. So theta is a 13.2. So I'm going to go 270 plus my 13.2 degrees plus 270 and I get my bearing of about a 283.2 degrees. Okay, real quick, to recap this problem. Okay, the first part, the distance is easy. That's just the law of sine. You guys agree? That is pretty darn easy to get. But the bearing, the thing about the bearing is you have to find these parallel lines to get it. You have got to find your alternate interior angles, because you need to find this angle so that you can subtract it from angle A, okay? And you get the Z. I knew that was 55. The whole angle is 55, and then subtract from the 41, okay? All right, you ready to turn the page? That's a pretty good problem, isn't it? Okay, turn the page. All right. Example 2. So, we want to find the area of this plot. Now, this is something that a surveyor would really do. And back in the day, before they had all the fancy stuff, they actually used a lot of trig to do surveying. Nowadays, they do very little because, you know, you can just get a signal from a satellite, push a button, you can walk across, push a button, walk across, push button, walk across, push button, and then go and put it in your computer, and the computer would, boom, print you a cool little picture. Okay, that's today. But we're not going to do that. We're going to have to actually do the math. So how do you do this? Well, first of all, we know what the area of a triangle is. The area of a triangle, the one I'm going to use, the area of a triangle, I'm going to use my 1/2 adjacent times the sine of the inclusive angle. That's the area formula I'm going to use. So I need two triangles. I'm going to first, I think I'm going to divide this right here. This would probably be the best place to divide my triangle, I think. And if I divide it in half like this, well, not exactly half, but if I divide it in two triangles, I've got triangle 1 and triangle 2. So if I want to find the area of triangle 1, I'm just going to use this formula. Triangle 1 is actually pretty easy. I mean, I really have everything I need for triangle 1. Triangle 1 is going to be the easier one. So right off the bat, area of triangle 1 is just simply going to be 1/2 times 124 times 85 times the sine of 100 degrees. Okay, so it's just adjacent, and the sine of the angle. Super easy formula, right? Use my calculator to get the area of triangle 1. So I go 0.5 times 124 times 85 times sine of 100, and I get an answer about 5,190, about 190. I can round it up. Okay, and that's in terms of meters squared. Okay, I'm going to circle that answer because I'm going to come back to it. Right. So I've got one of the triangles, but now I need to get the second triangle. So if I look at this formula, it's 1/2 adjacent times sine of the angle. Well, at triangle 2, I only have one side. That's all I have. I need this side here. I don't have. I'll call this C. I'm going to need that side, and I'm going to need this angle. So I got some work to do in order to complete this problem. Okay. The first piece I'm going to find is C. Okay, because I can find C from my first triangle. Okay. I'm just going to use the law of cosines to find C. So here's what I have to do. I need to find C, this side. Then I'm going to need to find this angle. To get this angle, I have to find this angle first and subtract from 130. Once I get the side and this angle, I can use my area formula. Okay? So let's go after C first. So if I take a look at my little triangle, I've got my side angle side. I can find my opposite side by law of cosine. So I'll set it up. C squared equals, let's see, I'll have a 124 squared plus 85 squared minus 2 times my 124 times my 85 times my cosine of 100 degrees. Okay, just use my calculator to do that work for me. And I don't know if you guys can see that. Put that up there. Slide it over. There we go. Now you can probably see the whole thing, can't you? There we go. So I'll go 124 squared plus 85 squared minus 2 times 124 times 85 times the cosine of 100, right? I need to square root that answer because it's C squared. So square root that answer, and I get about 162. So C is about approximately 162. Okay. Okay. So again, I need side. I need the angle. I've got the two sides, but I don't have the angle. So to get the angle, let's first call this angle theta inside the purple, we'll call it the purple triangle, the smaller triangle. So the purple triangle, right? And then once we get theta, we'll subtract it from 180 to get this angle. Let's call this angle alpha. I know, I love these little Greek symbols. Okay, so we got theta, we'll find theta. We'll subtract that from 130 to get alpha, and then we can do it, okay? So, alright, I can find this by the law of sines, right? I can go, okay, sine theta over 85 equals sine of 100 over 162, okay? So I'm just setting up my law of sines. I need theta. Sine of theta over its opposite side will equal sine of 100 over its opposite side. Alright, so cross multiply the 85. Sine of theta equals 85 sine of 100 over 162. I'll go 85 sine of 100 divided by 162, and I should get a decimal. Yep, and I'm going to take the sine inverse of that answer because I'm looking for the angle. And I get an answer about 31.1. So theta is about a 31.1 degrees, okay? Now, I can get the other angle. I can get alpha pretty easily because I'll just subtract. So to get alpha, I'll just take 130, right? 130 is the entire angle. I'll subtract my 31.1 degrees from that. 130 minus 31.1. I get an answer about 98.9. So this angle is a 98.9 degrees, okay? And I'll let you catch up. So what have I done while you're catching up? Well, the formula is my 1/2 adjacent times sine of the angle. That's my formula. So what I had to do is I had to find a side. I found that by the law of cosines. I have a side, so I got the two sides. I need to find this angle. To find this angle first, I had to find the angle from the other triangle so that I could subtract that from 130 to give me this angle. Now I've got my side, angle side. So triangle 2, I'm going to go ahead and find the area of triangle 2, 1/2 adjacent, which is 130, times my other adjacent, which is my 162, times the sine of my angle, which is 130. Oops, it's not 130. It is not 130. It's 98.9. And I'm just going to use my calculator to get the area of that. It's clear. I'm going to go 0.5 times 130 times 162 times the sine of 98.8. And I get an answer of 10,406. 10,000. It wouldn't make a huge difference. And then I'm going to take and add the two triangles together, right? Yes. Did I make a mistake, Devin? It's possible.
I got 403 also.
10,403.21.
What did I do wrong? 98.8 instead of 98.9. Oh, interesting. It did make a difference. 0.5 times 130 times 162 times the sine of 98.9. Wow, look at that. I got 10,403. Just a tiny little bit, didn't it? That's 10 meters. That's 3 meters. Yeah, that 3 meters, if the county was assessing me and taxing me on those 3 meters, it might cost me like a couple of bucks, right? All right. Thanks, you guys. So let's add them together. Total then is going to be 10,403 plus my 5,190. 5,190, right? And I get a grand total of about 15,593 meters squared. Okay, only 3 problems to do, all right? But I need you to draw them. I need to show all the work.